This is the first video of a series of videos where I walk through the final exam review homework that's going to help you prepare for the final exam in Stats 251. All right, so you can see that I got StatCrunch ready to go. I got my problems ready to go. I think I'm ready for number one. So number one, we got a discrete probability distribution that we can handle, probably even without StatCrunch, probably easier just to do this just straight up. It says find the probability that a household has one or two televisions. So just adding 1 and 2 gives me 40.48. Probability that it has 2 or more. So that's adding the probabilities of 2 and 3. So that would be 0.82. So that's 2 or 3, adding those two together gives me 0.82. Probability of it being 1 and between 1 and 3 inclusive. So it includes 1 and 3. So the only one left out is that 0.01. That's the only one left out. So these three should add up to 0.99. Because you know all four of these add up to 1 or 100%. So if this probability, 0 and 0.01, are the only one, that's the only one left out, then you know that the rest of them must be 0.99. Probability of randomly selecting a house that has at most 2 televisions. So that means that the one left out here is 3. So that means that these 3 then should take up the remaining 1 in the probability, so that would be 0.49, because 0.49 and 0.51 add up to 1. All right, so far so good on that. Number 2, another discrete probability distribution. So I think 1's okay. 2, another discrete probability distribution, but here they want us to find the mean, the population mean, given that discrete probability distribution. And here we do need StatCrunch's help. So upload the data in a StatCrunch. And there it is. There's the data in a StatCrunch. I just clicked on the icon to the right of that data. And now it's in StatCrunch. And to work with the discrete probability distribution, we'll go to Stat, Calculators, and then all the way down to Custom. We have our values under the column dogs. I guess in this case they just call it X, and then the weights in the probability column. And then we'll go ahead and compute that, and that tells us our mean. So the mean number of dogs in a house is going to be a little bit more than a half. They want us to round to 1 decimal place. So in that case it is a half of a dog is the average. With a variance, remember what we do with the variance is we square the standard deviation. So there's our standard deviation, and if we square it, I'll just copy that and maybe put that in the calculator up here and tell it to square that number. So there is the standard deviation that I found in StatCrunch. StatCrunch gave me the standard deviation. You can see there, I cut and pasted into the calculator and squared it. And that gives me 0.833. So rounded to 1 decimal place, 0.8 is the variance. That's just the standard deviation squared, 0.8. And then the standard deviation itself was, I believe, 0.9. Yep. Remember, it was 0.91. So rounded to 1 decimal place, 0.9. Okay, that's good. And now what? It says that the average house has 0.5 dogs with a typical deviation of standard deviation, same thing, typical deviation, standard deviation of 0.9 dogs. So that would be D. All right. So far, so good. 1 and 2. Number 3. It says in a survey of a group of men, the height of 20 to 29-year-olds has a normal distribution. So this is the group. It's normal. It has a mean, so right down the middle, 68.9 inches with a 68.9 is the mean with a standard deviation of 3. Okay, let's see. A study participant is randomly selected. What's the probability that that participant is less than 67 inches? 67 is just a little bit below average. There you can see that. There's that 67. Probability that's below that. And we can find that probability by finding the z-score and then using the z-table. I'm just going to use StatCrunch here for that. So for StatCrunch, we can go to Stat, Calculator, Normal Calculator, put in the mean and standard deviation. Mine is 68.9 for the mean, and then a standard deviation of 3. And now they want the probability that it's less than 67 inches. All right, so there's the probability. I'll just copy and paste that. Round to 4 decimal places. All right, let's see here. That should be good. All right, watch out for the rounding. Probability that it's between 67 and 71. So back to StatCrunch, and you can click on between. Ugh. Sorry, I didn't know that my thing was in the way. Sorry. Let me see if I can shrink that down a little bit. So just in case you didn't see it, good grief. Just in case you didn't see it from the previous one, I went to just a little rewind. Stat, calculators, normal. I put in my mean and standard deviation. It was 68.9. Standard deviation of 3. They wanted the probability that it was less than 67. So I got the less than symbol there, 67. There was my probability. I need to make sure I round that appropriate. The next thing they ask is, what's the probability that it's between? So I click on the between button. 67, and I thought it was 71. Let me just make sure. Between 67 and 71. Between 67 and 71. So StatCrunch should help me with that. Between 67 and 71. Make sure you hit this between button up here. That's where it's at. All right, and there's the probability. Can copy and paste that. And to 4 decimal places. That should do it. Okay. Probability that it's more than 71. So back to the StatCrunch calculator, get off of between and onto standard. More than or greater than 71. There it is. Copy and paste it in. To 4 decimal places, make sure you round the right way. Let's see, so my 19 will round up then to a 20. Okay, that's good. And now it says, well, is there anything unusual there? So, well, let's see, what's unusual? Unusual means that the probability will be less than 5%. Well, here the probability is like 26%. Here the probability is almost 50%. Here the probability is 24%. There's no unusual values, right? All the probabilities are more than 5% or 0.05. All right, 3's looking good, right? So what did we do so far? On 2, we went and we got, I think here we just did it by hand. Number 2, we went in StatCrunch, we went stat, calculator. For number 2, stat, calculator, and then down to custom. For number 3, we went stat, calculator. normal. That's not how you spell calculator, by the way. All right, but anyways, here we go. Number 4. Number 4 says, a population has a mean of 155, a standard deviation of 23. Find the mean and standard deviation of the sampling distribution, the collection of all possible samples. And they're saying, well, assume that all possible samples of size 48. So remember, for a sampling distribution, the sampling distribution on a sample mean is the same thing as the population mean. So let's see, the sampling distribution's mean is equal to the population mean, and the population mean is 155. Okay, so that's good, we got that down. And now what's the standard deviation of the sampling distribution for a mean? Well, it's the same as the population standard deviation, but then you have to adjust based on how big your sample size is. So you divide it by the square root of that sample size. So in this case, it's 23, but then adjust it by dividing by the square root of 48. My sample size was 48. So there it is. Let's figure out what that is. They want that to 3 decimal places. 23 divided by the square root of 48. 23 divided by square root of 48. That would be 3.3198. I don't know how they want to round. I thought they said 3 decimal places, so maybe this rounds, sorry. The mean for a sampling distribution is the same as the population mean, and that's 155. The standard deviation of a sampling distribution, sometimes called the standard error, is equal to the population standard deviation divided by the square root of n. Population standard deviation divided by square root of n. I think they want that to 3 decimal places, so that 8's going around that 19 up to a 20. All right, so let's get that in. The average, or the mean, for sampling distribution, all possible samples will have the same mean as the population mean. The standard deviation of a sampling distribution will be the same as the population standard deviation divided by the square root of n. All right, that looks like it's good to 3 decimal places. Next, looks like we're going to do a sampling distribution, but for proportions. It says 77% of all female heart transplant patients will survive for at least 3 years. That's the population proportion of female heart transplants survival rate after 3 years. 77% of them will survive for at least 3 years. And then they give me a sample. So they say, well, we're going to take a sample of size. So here's my sample. Sample data. Remember, this is a population parameter, right? This talks about the population. Here comes a sample. They say take a sample of size 80, right here. You can see it right there, 80, right there. 80 female heart transplant patients are randomly selected. So now we're talking about sample data. What's the probability that the sample proportion, that clues you off that we're talking about a sampling distribution, talking about the probability of getting a sample. What's the probability that a sample proportion, that's p hat, will be less than 73%? So they want to know the probability that a sample proportion will be less than 73%, or 0.73. Well, how do we find the probability? Well, we know that it's a sampling distribution. So for a sampling distribution, we need to know what is the mean of that sampling distribution for a proportion, and that's equal to the population proportion, which in our case is 0.77. And then what's the standard deviation for that sampling distribution? Well, that's that big square root that gives us our population proportion times 1 minus the population proportion divided by n. So let's figure that out. The square root of 0.77 times 1 minus 0.77 should be what? 0.23. One minus 0.77, 0.23. Divide that by n. N is 80. And now let's calculate that out. All right. Well, I can show you what I do in my calculator there. So I want, let's pull that down and get the square root. Square root of all of this, square root of, let me get one for the numerator too. 0.77, so this parentheses starts the square root, this parentheses starts the numerator. Now I'm going to close the numerator, divided by 80, and now I'm going to close the square root. That does it. All right, so that's 0.0471. 0.047. Well, they want that 4 decimal places. Okay. All right, so I got the mean. I got the mean for the sampling distribution. I got the standard deviation of the sampling distribution, and now I can find the probability that I want to find, the probability that it's less than 0.73. Where do I go? Is I go to Stat, Calculator, Normal, and then put in these values, the mean, standard deviation, and probability. So here I go. The mean is 0.77. The standard deviation is 0.0471. The probability that it is less than 0.73 is that. That's what we want. That's a pretty small, well, I don't know, almost 20%. That's not too small. We'll copy and paste that right into the answer. Round that to 4 decimal places. That bumps that up to a 9. Let's see what happened there. Round to 4 decimal places as needed. Oh, goodness. Going back to the normal calculator. That's not it. Back to the normal calculator. Make sure I got everything in there the right way. 0.77 is the mean. 0.0471 is the standard deviation. The probability that it's less than 0.73. Make sure that I got up. There it is. I forgot to divide it by 80 in my calculator, didn't I? Or did I? No, I didn't. It looks pretty good, right? It looks okay. 0.047. Maybe I should go 0.05 here. That brings it to 0.1976. 0.1976. Let's see if that makes a difference. Okay, so maybe word to the wise is that when you get this big long decimal in your calculator, take it out a long way. Do as I say, not as I do, right? I had to take that big long decimal out right here. I had to take it out further. So that did the trick. All right, so that's the first video in the series. I'll talk to you later.